Bethany, thank you, Peggy. Moving forward, it is my honor to introduce our closing keynote speaker, Megha Subramaniam. Is the Associate Professor at the College of Information Studies at the University of Maryland. Megha's research focuses on enhancing the role of libraries in fostering the mastery of emerging digital literacies that are essential for STEM learning among underserved young people. Megha is the lead PI for the IMLS-funded Graduate Certificate of Professional Studies in Youth Experience, co-leads 2 other IMLS-funded projects, Code4Lib and Safe Data, Safe Families, all intended to bring research and practice together to enhance the skills of in-service and pre-service youth librarians. Her first access to a computer was when she was in college, and she learned to code from a friend. When she formally took her first coding course in college, her professor specifically said to her that she would never be good at it. She is determined to bring the experience and joy of coding to underserved youth across the world. Megha currently serves as a fellow for the Libraries Ready to Code project led by the Office for Information Technology Policy at the American Library Association. So everyone, please put your hands together for Megha.
Good morning, everyone. So it's really nice to see most of the crowd that I saw on Monday. I don't think the crowd actually lessened. I know it's tough being on Friday and the last day of the conference, and today's the opening day, well, kind of the opening day for Black Panther. So I know a lot of you probably will be heading there after this, right? Me and my kids, that's our Friday night plan today. So I'm really looking forward to that. I'm also really looking forward to speaking with all of you, engaging with you today. So it's always kind of awkward to hear people introduce me when I'm actually right in front there. But thank you so much, Mary, for the lovely introduction. Thank you to the Code4Lib committee for inviting me for the conference, and those of you who thought that I'll have good things to say today. So hopefully it will be beneficial to all of you. I want to do a special shout out to University of Maryland's alumni, Jamie Mears, who actually did a lot of things at the event today. So I'm really, really proud of Jamie. Thank you, Jamie, for doing this. And I'm actually recovering from a cold, so I apologize for my voice. It might just crack at one point. And I know it's probably not so painful for people who are listening here, but people who are listening with their headphones at wherever they are, that might be a little bit more painful. So I do have a confession to make before I get started. I was actually very perplexed that I was asked to talk about whatever in this keynote, right? So typically when I give keynotes, the organizers give me a topic, give me strict dimensions on what I can talk about. Sometimes I feel like they're telling me what to say, but here I had this flexibility of talking about whatever that I want. So I hope Code4Lib community will continue to do that because I think that's really great. So I am going to take that opportunity to talk about whatever that I want today, and also to engage all of you to help with some of the larger initiatives with underserved youth that I'm working on. So while you're all here to hear me talk, I'm more interested to see how all of you can help. So I'll tell you a little bit as we go on. So today I'm going to talk about libraries as a player in computational thinking, and why should we care? Why should libraries care about computational thinking? So I'm going to tell you a little bit about myself, the type of work that I do, and then we'll proceed to the actual talk for today. And I always think it's good to know about the speaker before you hear about things that I want to tell you about. So I teach in the Masters of Library and Information Science program, specifically in the Youth Experience Specialization that I helped develop, the Diversity and Inclusion Specialization that I also helped develop, and the School Library Specialization, and also courses in our PhD program. So my broad research agenda is to investigate how underserved and disadvantaged young adults use libraries for the development of digital literacy skills essential for STEM learning, and also how libraries can actually play a role in developing and sustaining young adults' interest in STEM. So the young adults that I work mostly are middle school and high school kids. But in recent years, I've broadened my research to define youth from birth to 18, because I really think a lot of work that we do in terms of developing digital literacy need to start much, much earlier. So to achieve this broad research agenda, I have two threads. One is I work directly with young adults to leverage the strengths in the library by creating learning environments that help them develop digital literacy skills and also increase their STEM interests. So for example, just a couple of blocks away from here, I worked with a few schools, school libraries in the DC public school system, where we leverage the interests that youth have in science fiction and science-infused media. In fact, when I started that program was when the first Marvel movie came out. So we leveraged that interest and also librarians' knowledge about fiction and movies, and then we encouraged youth to produce science stories on their own using various formats. This really, really built their interest in terms of STEM. The second thread of my research is that I work directly with librarians to enhance their skills and abilities to facilitate digital literacy and also inspire STEM among the youth that they work with. So essentially in the second thread, I bring research and practice together to enhance the skills of the librarians. And I work with both pre-service librarians and also in-service librarians, so librarians who are practicing. So for example, the Graduate Certificate of Youth Experience, which was funded by Institute of Museum and Library Services, that I co-developed with my colleagues at Maryland, we train librarians to facilitate such learning, the learning that I talked about. We also engage youth to be speakers, to be designers of the program, so that librarians don't actually make up all these programs, but engage youth to co-design those programs with them. I also started bringing developments from learning sciences, youth development, human-computer interaction, and we brought all those developments on how they work with teens to get feedback on technology that they design. We brought them into librarianship. So in alignment with the second thread today, I'm going to talk about the Libraries Ready to Code project. So I'll begin with the state of the information sector, which was recently produced by the Bureau of Labor Statistics. And then I'm going to move on to things that I would love to chat with the Code4Lib community, which is computational thinking. So I'll give you the definition, which I would say this is a definition from definition that I have been using. There's a lot of definitions that are out there, and that definition is still evolving. And then I'm going to share with you 3 examples of what libraries are doing. This is from the project Libraries Are Ready to Code. And then I will also share with you why I think libraries could be a player and should be a player in computational thinking, especially in young adults. And then I'll also share with you where youth librarians need help, and that is where I think all of you can play a role. So hopefully we'll have some time to do some Q&A, but mostly during the Q&A time, I want to know how all of you can help. Okay, so let's get started. So I know you can't really see that, but the new employment projections data, now you can probably see, I highlighted some stuff. So the new employment projection data from the Bureau of Labor Statistics for 2016 to 2026 that just came out a couple of months ago, I think in October. So this report actually highlighted that the information sector, so in the sector that most of us are in, is projected to have 5 of the 20 industries with the fastest growing output, 3 of which are the fastest growing real output industries in the economy, and they are all information related. Increased use of mobile devices, addition of software to basically everything that we use, from car to dishwashers, will actually create demand for application for software developers. And then as more devices are connected to the internet, the need to combat cybersecurity threats will also increase. So in the next 10 years, half of all new STEM jobs that are going to be created are all going to be computing. But wait, this is really not surprising, right? For us, right? We've been hearing this for a long time. And what is interesting is this computational plus X, as people call it, is influencing research and practices in nearly all disciplines. So in the sciences, in the social sciences, in the humanities, computational thinking is transforming biology. Computational thinking is transforming archival science. Computational thinking is transforming neuroscience, microeconomics, and also the humanities. So really, this is not new news for us, right? So the term computational thinking came way before 2006. I know that you see the definition on the slide. The first definition that I put there is in 2006, right? But even before that, we've heard about computational thinking. So this is not a new term. But Janet Wing, who was a professor at Carnegie Mellon University, now I believe she works for Microsoft Research. She's the one that popularized this term, computational thinking. So she says that computational thinking includes a range of mental tools that reflect the breadth of the field of computer science. Computational thinking is a fundamental skill for everyone, not just computer scientists, right? So it was interesting because she wrote this article in 2006, and I can tweet out this article later. She wrote this article when most computer science departments were actually closing shop. So this is when she came up with this, saying that, hey, computer science is important, but not just for people who are thinking of majoring in computer science. Computational thinking is fundamental skill for everyone. But she really didn't define what computational thinking is in her first article in 2006. But in 2010, she attempted to define it, so which is the thought process involved in formulating problems and their solutions so that the solutions are represented in a form that can be effectively be carried out by an information processing agent. So she did define it the second time. And I would say when she started talking about it in 2006, that's when the whole computational thinking term became really popular. So computational thinking, she says in her 2010 article, is a new literacy for the 21st century. So she says that if someone has computational thinking skills, they are able to understand what aspects of a problem are amenable to computation. They are able to understand and able to evaluate the match between computational tools and techniques and a problem. They are also able to understand the limitations and power of computational tools and techniques. So Janet Wing actually breaks this down to 5 mental processes. And I know that some of you may already know this, but I like us to get started with a working definition that all of us can use. So the first mental skill that she talks about is decomposition. So when one is faced with a problem, you can break it down to smaller, more manageable parts. That's decomposition. Pattern recognition needs to be when they look at those parts and can see if there are commonalities, so that solving one part can actually solve a number of parts. Abstraction is when they're able to focus on things that are important and not pay attention or become overwhelmed by the details of the data that they're getting. Algorithm is being used very, very broadly these days, right? You hear the word algorithm, and in fact, I think among all this computational thinking mental skills, algorithm is probably the one that's most talked about. So algorithm is an abstraction of a process that takes that input, executes a sequence of steps, and then produces an output to satisfy a desired goal. Automation is another word that has been used a lot and sometimes kind of out of context. Automation could be how other people can enact the solution without the person who actually made it being there, since they've already elegantly laid out the step-by-step clear algorithm. That may work here or may work at another context or at another time. So we now have a working definition for computational thinking. So let's look at the library's Ready to Code project. So there is so much growing interest in computational thinking that libraries now have been tapped to facilitate computational thinking and coding program. So just this October past year in 2017, the American Library Association's Office for Information Technology Policy, which has an office here in DC, with the support from Google, they gave out $500,000 grant to 28 libraries across 21 states plus the District of Columbia to design and implement coding and computational thinking programs for young people. So this project is still ongoing. And as you can see, right, you can see from the map where these libraries are distributed, and you can see there's a gap there in the middle, and I hope some of you are from those states in the middle, because you can definitely help out for us to get people going there with computational thinking and coding programs. So this grant was this part of this huge initiative called Libraries Ready to Code. And this is the first time, I believe, that ALA has dedicated funding in such a large scale for computational thinking and coding programs in libraries. So I'd like to show you some examples of what these libraries are doing. And I'm going to share with you 3 examples today. And they have different flavors, different strengths. They also focus on different age groups between that 0 to 18. So one will be for younger children, one will be more towards the tween age, so 9, 10, 11, 12, and one will be for teens. And you start looking at how computational thinking is in action there. So this first program is from DC Public Libraries. Do we have any DCPL librarians here? I just see one hand there. Okay, so I actually was able to observe this program. This is called Ready, Set, Think for pre-K to second graders and also their families. So parents come along and participate in this program. So this whole session runs for an hour in the evening. I think it's right after school. So you can see that they have 4 rotating stations there. So the librarian sets up 4 rotating stations. And this is completely unplugged, right? There's no computers. They're trying to learn that the 4 mental skills of computational thinking. They didn't really do automation, but they just did the 4. So as you can see, for decomposition, the kids are trying to tie a shoelace, but they are not doing it. They work with a group of kids. One of them will be giving instruction to the other on to tie the shoelace. So essentially breaking a huge problem, which is tying a shoelace into smaller parts, right? And you may think that's easy, but when you're telling someone else to tie their shoelace, it's not really easy. And the kids get frustrated, and sometimes there has to be some anger intervention that needs to come place between the librarian and the child. So it was really fascinating to see the kids trying to tie the shoelace. And in fact, I might tie my shoelace very differently than you do, right? You have different styles, right? So this is an unplugged way of teaching decomposition. And then pattern recognition, I think the picture kind of tells you what pattern recognition is. And then abstraction is another place that I thought was pretty challenging for the kids. So what the librarian did is that she gave, they all take turns in a group. So one person will get a stack of cards, and they choose one card from there, and the card has a word of an object. So it could be a rainbow, it could be a tiger, it could be a cat. I heard the cat references is very popular among all of you, so I had to use that. So then this child that gets the card has to draw the object, right? But abstraction is that you need to remove all the things that are not important, but focus on the things that are important. So when they're drawing, they need to figure out how can they draw so that the person who is watching them draw can actually guess the picture as soon as possible, right? So they need to think a little bit. And there was a lot of frustration there too, but once they got it, I think it went really well. So for example, when you're drawing the rainbow, they just started drawing like this, and the people guessed it, right? You don't actually have to start coloring it or anything. So it was really, really fascinating to see these kids working. Algorithm design is basically creating instructions to move objects around a board. As you can see, they built like an obstacle course, and they needed to create instructions so that another person can execute that instruction. So that's a program, computational thinking, still running for younger kids and their families. Before the kids go home, the librarian actually has a packet of all these activities except for the Legos. I don't think she was giving out the Legos, but otherwise, everything else is there. They can do this at home. So let me describe a little bit about the demographics of this population that is participating in this program. And I got the information about the demographics primarily from the librarian. I just asked her. And that's because some of these are kind of hard to get, data that's hard to get. For example, socioeconomic status is not just income, right? There's educational background, there's other things that need to come together to evaluate socioeconomic status. So I just asked the librarian about all this. So you can see the map of DC there. It's offered in 4 branches, Petworth Library, Woodbridge, Francis Gregory, and Capitol View. In terms of demographics, the indicator that you see in the bottom for each, technology access at home, socioeconomic status, technology expertise that's needed on the librarian to offer the program, and partnership availability. So you'll just see icons on top there, right? I'm just going to explain this once so that the next time we see this again for the other libraries, it all makes sense. So if you just see one icon, that means it's in the low side. If you see 2, for example, the partnership availability here, you see 2, it's moderate, and then 3 is it's high. So in terms of access to technology, the librarian said that although these kids have technology access at home, it's mostly on their phone and all using their parents' phone, right? So having a phone doesn't really allow you to do a lot of things on it, right? It's pretty restricted. And from my experience working with DC public school kids, a lot of them have shared computers at home. So a whole family will share a computer. One time I was talking to a middle school kid as part of the program that I was running, and he was saying that he never gets to use the computer at home because his grandmother was always on Facebook on the computer. So he was super frustrated. But you can see the struggle that the kids have, right, when you have only one computer at home. So I categorized that as low access to technology at home. Socioeconomic status, all these 4 branches, except for one branch, has very low percentage of people who have college degrees. It ranges from 13 to 32%. So it's very low. And in 2016, there was a report that came out that was produced by the library. 46% of children living east of the Washington, D.C.'s Anacostia River live at or below poverty levels. In terms of technology expertise that's needed for the librarian to run that program that I just described to you, basically none, right? No technology expertise needed, except for the understanding of what computational thinking is. Partnership availability is medium, I would say, because the librarian said that in order for her to run this program to get people to come, she reached out to DC public schools. They actually have a very good relationship with the school system, and they recruited the parents to come, the kids to come, and also through the homeschool networks. So that's the first program. So now, I'm going to take you to Homer, Alaska. Anyone here from Alaska? No, I thought so. So this program is called Maker to Mentors. This is offered at Homer Public Library in Alaska. Now, I'll give you a little bit of demographics of this community, but let me tell you a little bit about this program. So these are middle school students, 11 to 13 years old. They learn how to code at a weekly program. So the program runs for 7 sessions, and there is 4 sessions after that for them to do the mini design challenge ideas that you see on the slide. So the first 7 session introduces them to key computer science concepts like functions, variables, loops, conditions, and all that. And then they have 4 sessions, which is dedicated for them to use what they have learned to complete this design challenge, where they actually not just use the coding skills that they have, but also computational thinking skills. So the mini design challenge is all the prompts that you see on the board, on the slide, and such as creating an animated music video, 2D flying game, choose your, do an animated PSA and all that. And I think they use Scratch in order to do this. So Scratch is a block-based programming language, so it's easy to use, and they have a lot of fun. Let me tell you a little bit about Homer. So you can see where the Homer Public Library is from the map. The librarian who's running this program is the only youth librarian. She doesn't have staff. She's the only person. Homer is about 218 miles southwest of Anchorage, and the Homer Public Library is about 25 miles away from the city of Homer. And this obviously is a rural area. So I asked the librarian about technology access and all the questions that I asked the DC Public Librarian as well. She said that about 50% have internet access outside of the school. In terms of socioeconomic status, a bit better than what I told you about DC, but at least 50% of the kids they qualify for free and reduced meals at schools. However, cost of living at Homer is very, very high. So many youth cannot really go to after-school programs unless it's offered through the library. The technology expertise that's needed from the librarian to run this program, I would consider this moderate because she does need to know how to code and definitely needs more technology expertise than the unplugged activity that I showed you earlier for the DC Public Library system. Partnership availability, this is where it gets really, really depressing. She says that as far as she knows, there are no computer scientists near close to the city where the library is located. Maybe there are some people who are engineers, right? But no computer scientists. No computer science schools offered in high schools in the neighborhood. So basically, these kids are deprived from computer science. So what she did, which I thought was really, really good, is that she tracked down computer scientists who are successful, these are people who are Alaskan born. So she was able to bring in the creator of a shopping network called DOTE, D-O-T-E. She was Alaska born. So she came through Skype virtually and talked to the kids how she got to where she is from. And she said that was really, really inspiring to the kids. So this is how this community really takes whatever that they have and makes the best of it. The last program that I want to share with you today is this program offered in Seattle Public Library. Do we have anyone from Seattle Public Library here? Yeah, okay. So this is also another fascinating program. This is called Build a Computer and Beat the Clock program. This program is inspired by the slowest computer in the Earth emulator. Has anyone heard about that? Oh, you have to look it up. Look up slowest computer in the Earth, and you will find that screen that is on your lower left. Right? This is a program that's designed by two game designers, Kaho Abe and Ramsey Nasser. And I think they're based somewhere in New York. This is a computational thinking heavy program, but without using any computers at all. It's perfect for the teens. So in this program, they build and program the slowest computer in the world using sponges. As you can see, all the yellow stuff on the slide are sponges. They use Post-its, they use markers, and they use tapes. So the teens are actually given a set of instructions on how to order the sponges. They order the sponges 10 by 10. The librarian had a great time going to the grocery store and buying all the sponges. He tweeted all the pictures. They will arrange it 10 by 10 with the yellow facing up. And then they build the axis on two sides with a tape making the shape of L. And then they write 0 to 9 on the masking tape for both the column and the rows. And then just underneath there, they arrange 16 Post-it notes in 2 rows of 8. And they label it from A through P. So the grid of the sponges is actually the screen of a computer. And every sponge is a pixel. So the pixels will be turned off when it's yellow. It will be turned on when it's green. So Post-it notes that are arranged right under the sponge, they are the memory. And each Post-it notes is a cell within the memory. So then, once they're done with all that, they get a set of instructions, right? Without knowing what the picture that's going to produce. So essentially, what you have to do is follow that instructions, and certain sponges will be flipped, right? So then you'll see a picture. There you see a smiley face picture. Right? So they have to follow an instructions, but they will not know what is the picture until they are done with it. And it's a competition. They have small groups who can do it fast. So the instruction will be like plot, which means you have to flip the sponge. They have set, which means you have to write a value for memory cell. There's 7 pieces of instruction. I can give you the whole lesson plan if you're interested in this. But this is something that is being offered at the Seattle Public Library system. So it's offered at the Douglas True, Rainier Beach, South Park, and Beacon Hill libraries. And what was interesting is that when I talked to the digital services manager, who actually had connections with the game designers, the 2 game designers that came up with this game, he said that although Seattle is located in a place where there's a lot of computing industries, it's really interesting because the population, the kids that come to the library, are kids who only have access to technology using their cell phone. And said most of them don't really have access to computers at home. Again, we're talking about the same thing that I just said. Socioeconomic status is also pretty low, with many recent immigrant communities. And technology expertise that's needed for the librarian is, I think it's somewhere between the DC one and the Homer one, right? Because you need a little bit more understanding on how the actual game transfers into computational thinking. So the two game designers actually came to Seattle and they trained their librarians to do this. What was really fascinating is that not only the librarians participated in this training, there were a few youth that they tapped through their partnership with Park and Rec and also Boys and Girls Club to come in and go through the training with them. So then when the actual program was run, the youth are the ones that were running it. The librarians were just supporting the programs. And believe it or not, the kids had more fun and they learned from each other as they were doing this. All right. So why libraries for the development of computational thinking? Now that I've showed you 3 examples, and I think I'm running out of time. Okay, so the first reason is libraries increasingly are embracing the connected learning approach to offer programming to youth. What is this connected learning approach? So all the programs that I had showed to you earlier, the 3 learning principles that is tied into all these 3 is they are interest-driven. We are tapping the things that the kids are doing already, the things that they are interested in, everyday life things, and bringing them as a program to facilitate computational thinking. They are peer-supported, meaning the kids are learning from each other, learning from their peers. The librarians and the adult mentors are there to support them. And they are academically oriented. That means it bridges formal learning and informal learning, but really they don't really see it. It actually bridges that. Right? So since the mental tools that are best learned, the mental tools that I'm referring to is the computational thinking mental tools. These are best learned through the development of dispositions such as collaboration, persistence, resilience. Libraries actually have the ability to provide youth with a range of mental tools that I just explained just now. And in an informal setting, without the pressure of being graded, and it's okay to do it wrong, to do it again and again and again. And to do it in a group and trying to figure that out, that's even more powerful. I thought I like this image a lot. So library programming actually allows learning and not necessarily focused on teaching. We are not teaching these kids, but we are facilitating the learning. So for me, computational thinking is not something that can be taught. Rather, it is learned through how generally young people learn. They learn by observing, they learn by imitating, they learn from their friends, and they follow trends. Another powerful way that libraries play a role is computational thinking can be learned even by the youngest person. I have librarians as part of the library ready to code who are using story time to embed computational thinking. So meaning computational thinking can be developed in children in a young age, even before they learn any type of computer science in formal classrooms. By doing computational thinking in libraries, we can demonstrate relevance of the CS plus X that I started out in the beginning. In fact, librarians mostly have that background in X, right? So it could be humanities, it could be any social sciences. And the partners that we have within our communities is also the X. So connections are more clearer when the librarians make that connection between CS plus X. And I put this the last, the clear one why libraries for the development of computational thinking is libraries provide physical, intellectual, and social access to computational thinking and coding that youth currently don't get at home. And I put this the last because this is where librarians always speak up first. They always say we provide access. But all the other things that I mentioned, they completely, kind of not say that whenever I ask them. But that also happens, and that's why I think libraries are more powerful in terms of facilitating development of computational thinking. So, Code4Lib community. This is where I want to engage you because all of you have that computational thinking skills and have the computer science skills, coding skills. Many of you do. So, this is where you can help. And this is where I see there is a need with the public and school librarians that I work with. What computational thinking concepts should be facilitated and when? When I was talking to you about the DC, the Ready, Set, Think, the stations. So I asked the librarian, she's actually a student in my program. I asked her, how did she come up with it? She said she Googled it, she tried to find it, she couldn't find anything for that age. So she started thinking about it and started coming up about it with her classmates. She was talking to them and figuring it out. It's sometimes really hard to figure out this type of activities without someone to talk to, right? Someone who has that knowledge on computational thinking. And I think this is where that all of you can be helpful. So when do we do this? Are there specific things that we can do with younger children? Are there specific things that we can do better with the teens? How to facilitate? This is also an interesting question. What prompt should we be giving to kids so that they can recognize the pattern? When to prompt it, right? Because when you're tying the shoelace, right, you're using the loops, right? So you have to prompt them with specific questions so it registers to them that they are actually using computer science concepts there. So facilitations needs to foster computational thinking concepts, computational practices, and how can librarians be more comfortable facilitating this, especially with concepts that they're not really comfortable with. How do you find technology experts to help? So this is where I think all of you come in. There are some times when youth librarians really need an expert and they really want to do the program, but they don't have the expertise, so they don't. How to assess learning of computational thinking in libraries? What instruments can be used? Can the learning be assessed by the artifact that they produce, right? How do we do that? So these are the areas that I believe the Code4Lib community can help with. And so please reach out. Please reach out. Either you can reach out to me or reach out to their school or public librarians that are in your community. When I showed you the places earlier, I will put the slides after this. I just didn't want to, I want to be a little bit more, I guess I want to keep the suspense. So I just did not put my slides before. So with that, I want to thank the Libraries Ready to Code team, Marika Wissel, Linda Brown, and Caitlin Martin for helping me out with this presentation. A lot of these ideas came from all the team members. I want to give a shout out to these three librarians who are doing amazing work: DCPL, Paula Langsam, Homer Public Library, Claudia Haynes, Seattle Public Library, Juan Rubio, and then Christy Kodama, who helped me with this presentation. Thank you, everyone. I think we have 5 minutes for questions. I'm sorry. Please come and see me after this. Any questions? Everyone is really tired.
Oh, I just wanted to, first of all, thank you for really concentrating on how to think about computer problems. I was fortunate enough that the first book I read in computer science class was one called, excuse me, How to Solve It, which goes over a lot of those kinds of things. It's actually written by a math professor, but it has how do you solve logical problems? And it was actually the most useful things, because I often work with students who can code, but they can't think about how do you solve a bigger problem. And these kinds of skills are just, really fabulous. So thank you very much for looking at the low-level things and trying to bring kids in.
Thank you. I just wanted to comment that I don't know if you're aware of this, but the high school course AP Computer Science. Did anyone take that course when they were in high school? Yeah. So I have no comments about the course. But now they have AP Computing Principles, which actually breaks down all these principles. I think this was maybe just 2 years ago they started it. Thank you for the comment.
So I'm a community college librarian, and I'm wondering about how we can teach these skills to our adult learners.
Okay.
Many of whom in our community, where the logging industry went bad, fishing industry, all of these people making the transition, and they're adults who don't have computational thinking. So thoughts about how we can help that with our adult learners?
Yeah, that's a great question. And I think it's pretty similar in terms of approach, right? But then again, you also, so I teach mostly adults, right? Because I teach in the graduate program. So the approach, you also have to appreciate people's ego when they're coming to this programs, right? So one of the ways that you can think about this is to ask them to learn from, so let me phrase this much better. So one of the strategies that really help is this intergenerational learning, and especially when the child or the younger person that's teaching is the person that's closest to you, that comes from your community, or is your child or your grandchild, right? So the intergenerational learning is really, really powerful. That's one thing to consider. The other thing is, because they are all going to be adults, really their approach needs to be, you can't ask them to tie the shoelace, right? It can be something like the example that I gave from the Seattle Public Library. I think that would be more challenging. And even having one of them to facilitate that session, I think that will also be helpful. Thank you for that great question.
Hi, I'm wondering if you're familiar at all with dynamic land, which is very similar to some of the work that you're doing, but kind of takes it to the next level with, in terms of computing together without screens on a table in a physical space.
I'm not familiar with that, but I hope you can share that with me, and I would be happy to bring it to the Libraries Ready to Code team. Thank you for sharing that. Yep, thank you. Thank you so much, everyone. Safe travels.
Okay, everyone. Again, thank you to Megha. It was Megha as well. We are going to go ahead and take a break. Before I do, though, you Lightning Talk speakers, you know who you are, and you wonderful final session speakers, you know who you are. During the break, could you please come up with either your link or your thumb drive, etc., and we're going to get the sessions done. So please come back here around, I don't know, 10:15. We'll say 10:15. See you in 10:15 and come back because we have giveaways. So we'll see you then.